Hello guys. So I was sort of doing a video in a lecture hall before, and I got kicked out by the security guard. I have to start again. It was quite funny really. So without wasting, I'm trying not to waste time. So without wasting much time, as I said, we're going to start from where we stopped the last video. We stopped at two main identities for sum and difference of angles. Okay, so for the first one, we had cosine of A plus B is equal to, I hope my camera resolution is good enough, is equal to cosine A cosine B minus, which is really interesting. There is it's like opposite. Whenever you have the operation to the positive, you have the inverse operation and the trigonometric function. So minus sine A sine B. And the other one was you have cosine of the difference of two angles. That's equal to cosine. It's really the same thing, but you can sort of, I don't know if it's inductively or deductively prove that if you have a positive operation here and it's negative, therefore if that's correct, therefore if you have a negative here, you should have a positive here. It doesn't really work like that in the whole of mathematics, where you can just say, okay, if this is, say for the first one, you can just invert it for the second one. Yeah, so in general, things don't really work like that in math. In general, things don't work like that. But you can just use that ideology plus, plus sine A, sine B. Really, what I'm trying to do today is, I don't know how, okay, I think the resolution of my camera covers the whole board. Really, what I'm trying to do today is, I'm trying to cover up for sine and tangent. Afterwards, there's still a lot of things we have to cover in trigonometry, because trigonometry leads to how you understand plane geometry. Plane geometry is the geometry of two-dimensional figures, two-dimensional shapes like triangles, circles, polygons, and so on and so forth. Yeah, and well, the next thing, we're not going to be doing any geometry. Well, we're going to be doing geometry, but it's not geometry of shapes. It's more like geometry of lines, really. Well, yeah, sort of. It's coordinate geometry we're doing next, but we still have a lot to flesh out, to tear out in trigonometry. Really, yeah. It's possible for me to finish trigonometry in 2-3 videos, 4 videos at most. But I feel it's going to take longer than that because, well, I can do all the things you need to know for trigonometry. It's just, the more I think of it, there's still a whole lot of things. There's still a whole lot of things I can do with trigonometry. It's not just sine, cosine, tan. It's really, maybe as I go on, you're going to see the use of trigonometry. So, yeah, so that's what we stopped the last video. So for today's section, we're going to be covering the proof of sine, sum and difference of two angles for sine, and sum and difference for two angles in sine. We're going to do for tan as well. There will be a circular proof, and I'm going to do co-functions. Like, okay, I'll show you that later, and then I'll do some like 3. I don't know how many examples I have. Do some examples, and then next section we'll start from half and double angle identities, supplementary angles, and so on and so forth. Well, and also the goal of me doing this video is not really for me to show how to put numbers, because personally I don't like numbers really. I just like leaving things in variable form and then punching it into the calculator later on, because that's not Yeah, that's not what I'm. Yeah, well, I'm not going to be using numbers and all this. I'll just show you the proof, and you can verify it yourself. You can say 90 minus 30. You can use someone different as two angles and say cosine. So you can express this in a surd form. Surdic form. If you want to express, say, cosine 60, you can prove that cosine 60 is a 1/2 with 3 divided by 2. I don't know which one it is. Anyway, yeah, so yeah, so that'll be that for that. And then yeah, that's just the overview of what I'm doing today. So for sine, so the circular proof I was talking about was I'm going to show you something, because one of the things I'm going to do today is showing you that cosine, that sine of 90, let me write it bigger, sine of 90 minus theta is equal to cosine theta. And then I'll do for sine and cosine, then I'll just write the identity for tangent. And yeah, so yeah, that'll be that for that. So for this is going to come later, but first of all, I need you to believe that this is true, and then I'll prove it later on. So we have to derive sine from cosine. Let's say cosine of 90 minus a minus b. That's equal to cosine of 90 minus a. That's one angle minus another angle, just b. Right. So we say this. Is equal to, if it's the difference of two angles, so we use this. So this angle will stand for this whole thing. You can call this phi, lambda, whatever you want, anything you want to call it. So this is going to stand for wherever you see this. So we have cosine of 90 minus a, cosine b, plus sine this, sine b. Now, as I said before, cosine of 90 minus any angle is equal to sine of the angle, and so works for sine as well. So this is equal to sine of well, we're actually using minus, yeah. So that, yeah. Wow, I don't know that thing. Give me a second. Let me go what I'm doing properly. Okay, minus that. Okay, using minus plus. Okay, so we have that sine. I see minus a minus b. Cosine a minus b. Yeah. Cosine. Well, let's just do this part first. So cosine 90 minus a, that'll be sine a cosine b plus cosine a. This whole thing is cosine a sine b. Really, this is meant to be sine a plus b, but there's a mistake somewhere. Okay, well, I think I'll do this later, but it is sine A plus B. Okay. Anyways, so that's that for that. Well, we can also use the fact that the way we kind of wrote this one out, that sine of A minus B is equal to is equal to sine A cos B minus cosine A sine B. So we have these two functions. Now we want to do for tan. So we know that tan x, where x is an angle obviously, tan x is equal to sine x divided by cosine x. Basic trigonometry stuff. Or you can rewrite it as sec x sine x. That's another way of writing tan x, sec x sine x, because 1 divided by cosine x is sec x. So sec x sine x. That's another way of writing tan x. So if x is equal to a plus b, therefore tan a plus b is equal to sine a plus b divided by cosine a plus b. Give me a second to look at my camera resolution so that I see what I'm doing properly. Yeah, it's pretty wide enough. Should be able to cover it. Well, we know the expression for sine A plus B and the expression for cosine A plus B. So bear with me as I tilt the board a little bit. I'll tilt it down when I'm done writing it. Just want to conserve space. So tan A plus B is, tan A plus B is going to be, to expand this now. So sine A plus B is there, cosine A plus B is there. Sine A plus B plus cosine A sine B. All of that divided by cosine A cosine B, yeah, minus sine A sine B. That's actually really correct, but we want to simplify it. So what can we do to simplify this actually? Let's see. If I divide all through by cosine A cosine B, we have something good actually. So we have dividing all through by cosine A cos B. Hope you can see it. If we divide all through by cosine A cos B, so we have this goes to 1. So let's write it. So we say tan A plus B is equal to, so let's do the numerator first. So sine A cos B divided by cosine A cos B. So sine A divided by sine A divided by cos A, that's tan A. So cosine B cancels cosine B, cos A divided by cos A divided by, so divided by cos A, that's 1 times that, so sine B divided by cos B, that'll be plus tan B. Divided by 1. As you can see, that's true. Minus sine A, so cosine A divided by, so sine A divided by cosine A, that's tan A. Well, tan A is tan, well, just tan A. So we have that. I don't like the way it's arranged actually, so I don't like it better. So tan A plus tan B divided by 1 minus tan A. 1. Yeah. Okay, so that's that for tan A plus B. We can use the same way we had to prove this, and just invert the sign here. So tan A plus B minus B this time is equal to tan A minus tan B divided by 1 plus tan A. That makes sense. Okay, so take a moment to digest the proof. It's not tedious, is it? It's like, common, it's logical. We derive from cosine A plus B to cosine A minus B, some differences of both of them. That's really a short form of what I just said, and we did this. Really, to be honest, let's see, this part is quite tricky, really. Sine A cosine B plus sine B. Okay, so yeah, that's that for that really. I know this is correct, but I will explain this later on. This part, why it is sine A plus B. Now, without wasting too much of the time, so we have all these identities that are true. Just put that in your head, understand it. The proof actually gives you a feeling. When you just have this mathematical equations, it's one thing to memorize an equation, it's another thing to actually understand the equation, really. The proof, the derivation of an equation kind of gives you the feeling why it is true, what's happening, how that equation came to be, why the equation is written the way it's written. So that's about these are the major trigonometric functions. Well, except for hyperbolic trigonometric functions like cos, sine, tan, hyperbolic, and so on and so forth. We're going to cover all that later. So this is really everything, most of it. I've already done the rest. I've done for sine squared theta plus cosine squared theta equal 1, tan squared theta plus 1%. So on and so forth. Now, what I want to do is just examples based on what we already know. So I'm gonna have to clean. Well, really, I don't have a duster, So I have to sort of max optimize the space I have. So the first example, oh well, we're not actually done. We have to show why cosine 90 minus theta is equal to sine theta. Cosine, so yeah, and so on. So for the two main trigonometric functions, which are sine and cosine, because all other trigonometric functions are derived from sine and cosine. Sine and cosine are the only real. Well, in a way, cosine is actually derived from sine. So yeah. Okay, so I made a statement before, which I used to prove this. Cosine 90 minus theta. If we use this formula, you see that the first angle is cosine A, which is 90. So cosine 90 cos theta plus sine 90 sine theta, and that's equal to, this is 0, 0 plus sine 90 is 1, so that's equal to sine theta. I hope you can see it. Cosine 90 is 0 times anything, 0, plus sine 90 is 1 times sine theta. And you can do the same for sine as well. Another thing I need you to know is that just as this is true for sine and cosine, it's also true for cosec and sec. So we have this to be true for sine, and also that sine of 90 minus theta is equal to cosine theta. So we also have for sec theta equal to cosec 90 minus theta, and sec, well, sec of, say, cosec theta is equal to sec 90 minus theta. Really, yeah, that's about it. Okay, so now let's just do some examples. I have no duster. That's bad. Is there anything I can use to clean the board? Oh, well, I can rehabilitate it. Voila. I literally just forgot. So we have examples to do. What's the first example? Sine 2x minus 60 equal cosine 40. Let's solve for x, obviously. Sine 2x, is it minus 60? I think I don't know. Let's go to cosine 40. Now, let's see. What can we actually do? We have two separate trigonometric functions. Arguments are different. Somehow the arguments have to be the same thing. In order for the arguments to be the same thing, we have to express one of these functions in terms of the other one. So one of either this sine function in terms of this one, or the cosine function in terms of sine. So sine function in terms of cosine, or cosine function in terms of sine. Just like how you have, like, let's say you have 2 to the x is equal to 8. Yeah, and you want to solve for x. What you do is you introduce log 10 to both sides. So you have x log 2 is equal to 8. Well, is equal to log 8. Normally, in order to let's write like this, 2 to the x. Or let's say the equation was actually given like this, and you have to cancel log of both sides. Well, you know, the point is you cancel log of both sides, so you have 2 to the x equal 8. But to solve it, you have to introduce log. So that's the logic I'm using. Exponential functions. So we have to express one of these trigonometric functions in terms of the other one, so that we can actually cancel the function itself, so we have the argument left. So this is better because we have no variable in it. So we have sine 2x minus 60. You know, in real life, we don't actually use degrees. Okay, it depends. Especially in physics, we really hardly ever use degrees, or in calculus, we don't use degrees really. We use pi, because pi is universally accepted or true, so to say. It's more efficient. But to me, I kind of understand degrees better than understand pi. If you say 3 pi over 2, I'm like, what's that? But if you convert it to degrees, I'm like, I know where 2 pi I think sort of, obviously you can't give where 3 pi over 2 is and so on and so forth. So yeah, kind of, or negative pi over 6, you're like, what's that? Start thinking, well, if you kind of convert that to degrees, I'm like, okay, I know where that is, what quadrant that is. That'll be equal to sine of, let's see. I said before that cosine theta is equal to sine 90 minus theta. So if I said cosine 40, which is the angle there, is equal to sine of 90 minus 40. So we have sine 2x minus 60 is equal to sine 60. Cancel the functions. So we have 2x is equal to 60 plus 60, that's 120. I hope you can see that. Well, should I just write everything? 2x minus 60 is equal to 60. Take the 60 there, you have 2x is equal to 120, therefore x equals 60. This is a fairly easy question. I wouldn't say it's easy, but you have to understand how to change this. Okay, so what's the other question? Well, the other one is sine 2 lambda minus 30 equal negative. This is a good question, because I think this is what I did in my second video, or my first or second video. So sine 2 lambda minus 30 equal to negative half, equal to negative 1 divided by 2. Good question, isn't it? We'll actually solve for the variable lambda. Now let's keep in mind, if I'm solving a question, I'm actually showing you how I'll go about doing it on a normal day. So let's see, negative 1/2, what's that? Negative 1/2. We know that in order for us to have the sign of an angle to be negative, therefore the sign has to be in a quadrant where it's negative, really. What quadrant is sine negative? It's negative in the third quadrant and in the fourth quadrant. So 2 lambda, which is the angle, minus 30, is equal to, is equal to sine inverse negative 1 divided by 2. Okay. So what we do is we try to look for the quadrant where we have sine and how to reduce the angle in that quadrant where sine is negative. So in the third quadrant, we have to reduce an angle in the third quadrant. It's the angle minus 180 degrees. So remember that's for third quadrant. Is it RD like that? No, third quad. And the angle here is 2 lambda minus 30. So we have 2 lambda minus 30, okay, minus 180 is equal to sine inverse of, is it going to, let's see, is it going to be a half or negative a half, or negative 1 over 2? Well, if we are already reducing this in the third quadrant, so we have to actually change that to 1 divided by 2. Because we're already changing it to the reduced form. So it's this angle, if we solve for lambda, it has to be in the first quadrant, but if you add 180 to it, it will give you the angle in the third quadrant. So that's 2 lambda minus 210 equal to sine inverse of a half. And 2 lambda, well, this will be for the third quadrant, so you can solve this later on. And the other one will be 360 for the fourth quadrant minus 2 lambda plus 30, if you open the bracket, is equal to sine inverse of a half. Okay, so that would be that for that. So you can solve for lambda here. I have no calculator, so I have to just do it like that and let my audience do the rest. Next question, well, it's exactly like the first thing we did. Next one was tan 3x minus 5 equal cut my that's. So the next one is tan 3x minus 5 is equal to cot 90. This is fairly easy. Express this in terms of this. That will be tan 3x minus 5 equal to cot 90 minus 90, which is cot 0. Sorry, tan 90 minus 90, which is tan 0. If you don't know what tan 0 is, you can say sine 0, which is 0, divided by cos 0, which is 1, that will be 0. So you have 3x minus 5 equal 0, 3x minus 5 equals 0. Therefore, x equals to 5 thirds. Next one is based on your knowledge of trig functions and identities. So the square root of tan squared 25 plus 1 divided by cosec squared 65, I guess. That should be it. If you think for a while, how are we going to actually do this? Well, we know one thing for sure. What do we actually know? We know that, how am I going to do this? Okay. We know that tan squared theta plus 1 equals to sec squared theta, and we know that sec, I think that's what I meant. Sec theta is equal to cosec, as I did before. From here, sec theta is equal to cosec 90 minus 2. That's what we're going to use here. Cosec 90 minus there, and you can actually square both sides. So sec squared, that is equal to that squared. So you can literally just square both sides. So I can write this formula, whatever that is, or that question, as the square root of sec squared 25 divided by. Alright, it all makes sense now. 65. I hope you can see it. And if we expand this to cosec form, we have that sec 25 can be written as cosec 90 minus 25, which is 65. So that'll be cosec squared 65. Or you can see that the answer is actually just 1. Cosec squared 65, I'm just going to write it, that's equal to square root of cosec squared 65 divided by cosec squared 65, and all of that is equal to 1. Square root of 1 is 1. Yeah. Last question. Actually, 2 more questions really. The other one, the last one is the fun one. That's actually, well, it's proving, it's slightly the most tedious to work out. Yeah, because there's a time me and my friend used to solve these questions, show that, prove that, this equals that. You can see how tedious it can really get. So the last question is, because I have no dots and I'm trying to optimize my space. The last question goes, sine 20, it's a long question there. Sine 20, sec 15, tan 5, divided by 9 cosine 70. Cosec 75, cot 85. How would you go about doing this question, really? How would you go? Well, to be honest, you can go I can't say you can go different ways. Because if you start saying that sine 20 is 1 divided by cosec and bring cosec here, it's just going to make the whole thing tedious. But look at something. Look at all these functions: sine, cosine, sine, cosec, sec. They're all code functions of themselves. So really, if you think about it, this is equal to express the sine in terms of cosine. So that'll be cosine 90 minus 20, that's cos 70. I don't know if you can see that. So that'll be cos 90 minus 20, sec 90 minus 15, minus 15, tan, cot. Oh, this is a mistake. Sorry. Cosec, because we're trying to express in terms of cosec. Cosec 90 minus